Let's say you're given something that you need to take a derivative of, and you don't remember the rule. Well, how can you figure it out? Often, implicit differentiation is the answer. Say, for example, y equals a to the x, where a is some number not e. Now, most people remember that if y is equal to e to the x, its derivative is e to the x. What's the derivative of anything else? Well, let's see if we can figure it out using implicit differentiation. Implicit differentiation just says, hey, let's change the equation, and then we'll just take a derivative. For example, let's take the natural log of y. It gives me the natural log of y is equal to, well, I can take the x out front times the natural log of a. Now, when I take the implicit differentiation, well, the derivative of y is y prime. So the derivative of ln of y is y prime over y, because it's 1 over stuff times the derivative of this stuff. And then on the other side, notice that x is x. It's the variable. And the natural log of a, well, that's just a constant. So this is ln of a. So if y equals a to the x, y prime needs to be y times the ln of a. But y is a to the x. So this is just ln of a times a to the x. So I've just derived the rule that says, hey, I just multiply by the ln of a when I have an a to the x. And this begs a question that I like to double check. What if a is equal to e? Does this still work? Well, if a is equal to e, then that would mean we would have the natural log of e times e to the x. What is the natural log of e? It's 1. So this would just be e to the x. So it seems to work. And let me go ahead and box this answer, because it's one that a lot of people don't know right off.